Alright, how's it going? Today we're going to go over the dihybrid crosses, practice number 1. So what you should know from class is that a dihybrid cross is how two traits are inherited together. So we're looking at how you have both blue eyes and brown hair, or brown eyes and long fingers. Obviously, this requires a little bit more effort or a little more work than the monohybrid crosses. So what we're going to see is that we're actually going to have a 16 box Punnett Square, and that's because there's more options for the sperm or egg cells. So when you go through these problems, you'll just solve them like the other ones, but there'll be a few extra steps. So starting with number 1 here, you're going to read through it, and the first thing you're going to do, as always, is you're going to tell me what are the traits that you're looking at. So if you read through this one, you're seeing that the first trait is color of the pea, and the second trait is the shape of the pea. Step 2, you're going to pick a letter for those. So for color, I'm going to use G, and for shape, I'm going to use R. Step 3, you got to put out the options. So there's 2 options for color. There's yellow, and there's green. For shape, there's round, and there's wrinkled. So those 3 steps are just the same as we did before. The 4th step's really the same as well. It might take a little bit more effort in these problems, but it's the exact same. You've got to figure out which one's dominant and which one's recessive for each trait now. So it says pretty clearly right in the question that yellow peas are dominant over green peas. So that's pretty easy to figure out. That means yellow peas gets the capital G, green peas gets the lowercase g. And then it says round peas are dominant over wrinkled peas. So round peas gets big R, wrinkled peas gets little r. Now that you've got all that set up, all you have to do is figure out what the parents' genotypes are. So right here in the problem, it tells you that 2 plants that are heterozygous for both traits are crossed. That gives us all the information we need. So we have 2 plants. They're both heterozygous for both color and shape. So what you're going to do is you're going to write out heterozygous for both color and shape. You should think heterozygous means different. So that means you're going to get different alleles, which means you're going to get a dominant and a recessive, which we'll represent with a capital and a lowercase for each of the genes for both the parents. Alright, so you can see that I wrote down heterozygous for both the parents there, where it says the cross, big G, big R, cross, big G, big R, little r. Now what we have to do is we have to figure out what the possible sperm combinations and the possible egg combinations are. And how we have to do this is we have to think back to meiosis. In meiosis, we learned that sperm and egg cells are haploids. That means that they have one set of each gene in them. So what we need to do is we need to give the possibilities that we could match up one of the color genes with one of the shape genes and give all the combinations that we can come up with. There's a pretty simple way to do this. My favorite way is this method. Circle the first big letter there. Draw an arrow to the 2 opposites. So our first possibility for the sperm would be big G, big R. The second possibility is big G, little r. And then what you do is you just flip-flop it here. Circle the second letter. Draw an arrow to both the other options. So little g, big R, and little g, little r. You can do the same for the opposite side, except since it's the exact same genotype, it's going to give you the same options. So fill those in. And then you're just going to write those on the top and side of the Punnett Square. It doesn't matter where you put them. It doesn't matter if mom goes on top or dad goes on top or on the side. Now you just drop and meet them. So fill in your Punnett Square. Keep the G's grouped together and keep the R's grouped together. In other words, keep each trait grouped with within itself. You don't want to mix up the G and the R because that can get a little confusing. Always keep capital before lowercase, but again, keep the G's with the G's and the R's with the R's. Go ahead and fill in your Punnett Square, and I'll fill in mine. Alright, it's all filled in. That was some Punnett fun there. Alright, now what you got to do is you got to make a key for yourself. This is the most sensible part, or my personal favorite part. So if you go through, we know that round is dominant over wrinkled. So that means anywhere where you see at least one big R, it's going to show up as round. So what you should go through is you should go through and mark your Punnett Square and underline anywhere where you see one big R, because you know that those P's are going to be round P's. So run through them all. And then that leaves several squares that have little r, little r. Well, those little r's are because wrinkled is recessive. So anywhere where you see little r is going to be wrinkled. So go back through, underline any of the little r's. I used purple there for my key. You could use whatever color you want. And now you're going to do the same for yellow and green. Yellow is dominant over green. So that means anywhere where you see a big G, even if you just see one big G, it's going to be yellow. So all these guys will be yellow P's. And then anywhere where you see recessive or little g is going to be green. So you'll have green P there. Green P. All right. Now you're going to go through and you're going to write out your phenotypic possibilities. This is a little bit different than in the monohybrid. In the monohybrid, phenotype means physical trait or the physical features that you're going to see. It means the same exact thing in the dihybrids, except now we're interested in how two traits are inherited together. So instead of just writing yellow or round, you're going to write what percentage of the P's are yellow and round, green and round. All right, so it's important that you group the two traits together. All right, so now that you got them all color-coded, it makes life a lot easier, because when you're going through and you're counting each square, you can figure out what the ratios are or what the frequencies are a lot easier. So we're looking for yellow and round, so you just look for something that's underlined yellow and blue. Cross them off as you count them. It's going to make your life a whole lot easier, I promise. Just do it, don't ask. It's going to save you time. So if you count off there, 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 16 are yellow and round. Yellow and wrinkled, we're looking for yellow and purple on mine. It's going to be 3 out of 16. Green and round, that's green and blue. Again, 3 out of 16. And then lastly, green and wrinkled are all recessive. That's only 1 out of 16. Good way to check yourself is to add up your fractions and make sure they add up to 16 out of 16. If they don't add up to 16 out of 16, you probably did something wrong. So you should probably go back and check again. All right, from here, I'm going to just jump ahead to number 4 on this paper. I'm only going to go over 2 examples on here. I've already droned on for almost 8 minutes, and you get to hear me every day in class, so I doubt you want to hear me for much longer than another 8 minutes. All right, so if we go through number 4, you see it's a little bit more of a problem. First of all, there's only one trait, but that one trait is carried or caused by 2 different genes. That one trait's hair color. Hair color is what we call a polygenic trait, meaning that there's more than one gene that controls it. So since there's 2 genes that control hair color, it will act like a dihybrid cross when you're trying to figure out an offspring's hair color, or the chances of an offspring's hair color. So if you read through this problem, you kind of find out this family's history. You got Moolah, she's got some black hair, you got mom, you got dad, Moolah marries Cash, and you're trying to figure out what Moolah and Cash's offspring are. So the first problem is trying to decipher the problem. So what I suggest doing when you get these family histories is give yourself a little family tree. You got mom and dad, they had Moolah. Write down what you know about them. Tells you what mom has. She has regular blonde hair, and gives you her genotype: big O, little p, little p. It's going to be hard for me to write these out on this screen. And then dad has black hair, and he's all dominant. Moolah has black hair, we know, so we'll come back with that. She marries Cash. Cash is a ginger. He's got some red hair there. So he's got to be big O, little p, because if you come down here to the chart, you'll see that there's only one option for red hair. So if there's only one genotype for red hair and he's got red hair, he's got that genotype. So really the problem, or the crux of the problem, lies here with Moolah. We've got to figure out what Moolah's genotype is in order to make our cross with Cash. there's two ways you can go about solving this problem. One, you know mom's genotype, you know dad's genotype, so you could cross them and set up a dihybrid and figure out what Mula's genotype could be. That seems like an awful lot of work, and we want to be time efficient here. So there's a better way. If you just think about it a little bit, you can kind of solve this problem. So coming down here to the chart again, we know that Mula is going to have two possibilities for her genotype, because there's two possible genotypes for black hair. The first possibility is that she's all dominant, big O, big P, big P. The second possibility is that she's big O, big P, little p. The only difference between those two genotypes is the last P. She gets one dominant or one recessive P. So look at her parents. She has to get one O from each parent. She has to get one P from each parent. That means dad's going to pass on this O. Mom's going to pass on this O. Dad's going to have to pass on a dominant or capital P because that's all he has. All mom has is a recessive or lowercase p. So mom is going to have to pass on a little p, which means that Mula's genotype is going to be that one right there. Big O, big P, little p. Now we just have a simple problem to solve. Now we know both our parents' genotypes, so we're just going to set up the Punnett square. So set up a 16 square Punnett here. It's going to be beautiful. There we go. All right. And you have to figure out or FOIL both of their genotypes to figure out the possible sperm and possible egg combinations. So for Mula, the first possibility is you could have big O, big P. You have big O, little p. You could have then big O, big P, or big O, little p. For Cash, if you go through his, you're going to see his possibilities are really similar. He could have big O, little p, big O, little p, big O, little p, or big O, little p. So really he only has one combination. That's going to really simplify our Punnett square. Since Cash has all these repeats, what I can do is I can get out my black marker here. And anytime there's a repeat in one of the parents' sperm combinations or egg combinations, you can delete them because it's just going to give you the same outcome anyways. And it's going to save you a lot of time. So since all four of those are the same, we can delete the 3 copies and just fill in the one row that we know. Mula has some repeats too. She has big O, big P, and then another big O, big P. So I can put an X between the second one. And then she has a big O, little p, and another big O, little p. So I can put, again, cross out the second one. So that leaves me 2 blocks to fill in. That makes life a whole heck of a lot easier. It's going to save us a whole lot of time. We'll still get the same exact response. Drop them down, fill them in, and then use the chart to figure out what they are. So that first square there is going to be big O, big P, little p. So if you come down to your key, big O, big P, little p is black hair. So somehow label it. Blah. All right, go through, fill in the second one here. Big O, little p. Come down here. Oop, look. That's Cash's hair color. Red. So these two are going to have a 50-50 chance of having an offspring with red hair and a 50-50 chance of having an offspring with black hair. It asks for the phenotypic ratios. Phenotype is the physical feature. So black hair and red hair are your 2 possibilities. So either they'll have a ginger or they'll have a kid with black hair. That's it. Pretty simple.